Alright, in this video we are going to solve equations, and also in some problems we will determine the missing angle measure for angles that are formed by a set of parallel lines being cut by a transversal. So what we're really doing today is combining everything we've learned about with parallel lines cut by a transversal, and also what we know about equations and how to solve equations. I think in class we have skipped this step and gone straight to determining if the angles are congruent or equal or supplementary if they add to equal 180. The way that we know two angles are congruent is if they are vertical, and the way we know two angles are supplementary is if they're adjacent. What that looks like, what we've been doing the past couple of days, is I'm picking an angle and I'm going to color it in. I'm going to pick this angle and I'm coloring it orange. Well, the angle that's vertical to that, I'll also color orange to let myself know that those two angles are the same measure. Now, these two angles correspond with these two angles on the other parallel line, because they're in the same position. That means that all of the other angles are equal to each other, and we know that that's true because, one, the blue angle and the orange angle are adjacent, they share a side, but also these two, so that's how I know that this angle and the orange angle are not the same, and this angle that I'm pointing to is vertical with this angle that I'm pointing to, because they share the point. They are vertically across from each other if your paper is turned. Hence vertical angle. Okay. And then these two angles are in the same position as those two angles, so that's how I know that all four of those blue angles are congruent to each other. So this first part says that I need to know if the angles are congruent or supplementary. When it's asking about the angles, it's asking about the ones that it's giving you information about. So 2x plus 10 and 120, notice how they're colored in different colors. That means that they're not congruent, so they're supplementary, which means 2x plus 10 and 120 add to equal 180. So I'm going to write down that these are supplementary. And then I'm going to say 2x plus 10, the blue part, plus the orange part, 120. Because these are supplementary, if I add them together, I'll get a sum of 180. The two different angles, the blue one and the orange one, plus together, added together, equal 180. In class, a lot of us decided, we said before we even did any math on paper, that we knew the blue angle had to be 60 degrees. Because if these two angles are supplementary, 120 plus 60 equals 180. And that is absolutely correct. I gave us something like this so we could work up to something like the next example that I'll show. So I still want us to write this out, just so you can visually see what's happening with what you already know to be true. Now what we have is an equation. We're going to spend some time solving for x, because this problem asks me to find the measure of each underlined angle. There's not an underlined angle, so I don't really care that that's 60 degrees. I do want to solve for the missing value, though, x. So we're going to solve this equation for x by first seeing if I have any like terms on either side. On the right side, I notice I only have one term, so I'm going to have to drop that down. That's not a math thing, that's just going to make it so that all of my work is on one line. My entire equation will read on one line. That's just being organized. On the left side, though, I've got a term 2x. I have a term plus 10, which is not similar to 2x. and then I have a term plus 120. This is a constant. 10 was the other constant. Since I have two constants, and constants are all like terms with each other, I know I can combine those. So I know I need to have a plus 10 and a plus 120 being combined. And then 2x doesn't get combined with anything. 2x is positive though, so I'll put a plus sign in front of it. Well, 10 plus 120 is 130. So I'm just going to copy down all of my stuff again. 130 plus 2x is 180. That was the first step of in solving equations. We're just combining all of our like terms. So we had two constants on the left that we combined by adding them together. Our next step is to see to it that all of the variables, we want to collect all of the variables on one side of the equation. Well, all of the variable terms are anything that has an x in it, in this case because the letter is x. Well, all of the terms that have an x are already on the left side, so that step's already done. The step after that, well, if the variables are on the left side, then you want to get all of the constants on the opposite side. Since the x's are on the left, then we want all the constants on the right. And there's a constant, 130, that's not on the right, so we're going to have to move it over to the right. That's a positive 130 because there's not a sign in front of it. So to move it to the right, we're going to subtract 130 from both sides. $130 minus 130 is 0. And then I still have this plus 2x. And then 180 minus 130 is 150. Oh, sorry, it's just 50. 50. 0 plus 2x is just the same as 2x because you don't actually have to write the adding 0 there. So now what we have is 2x equals 50. That step, minusing 130, helped us solve the equation because what it did is it got rid of the constants from the left side, and now I only have constants on the right side and I only have variable terms on the left side. Now to isolate x, that's the very last step when we solve equations. To isolate x, we want to get rid of its coefficient. If I had to pick how to write this in words, to what operation would I put in words between 2 and x? Times, plus, divide, or minus. We would put times between the 2 and the x to say this out loud, or to write it down in words, 2 times x. So the opposite of times is to divide. To undo the coefficient 2 then, we're going to divide by 2 on both sides. 2x divided by 2, 2 over 2 is 1. So I'll have 1x equals 50 over 2, or 50 divided by 2 is 25. So 1x is 25. You don't really have to write the coefficient 1 though. You can just say that x is 25 because 1x is the same as x. So there was another little review on solving equations for us because I spent an awful lot of time on that. I'm going to really try to not do that for the rest of the video. We'll see how that goes for me. Okay, so first I'm going to pick any angle from these parallel lines cut by a transversal. I'm going to pick this angle right here, and I want to find anything that's congruent with it. So I'm going to first color in its vertical angle, so the angle that shares a point with it. And now those two angles correspond with the two angles in the same position, but on the other parallel line. And then any remaining angle I know is going to be congruent to any other remaining angle. So the two angles that we're looking at are 2x plus 10 and 3x plus 15. One of them got colored with my first highlighter orange, and the other got colored with the other highlighter blue, which tells me that they were not the same measure. Since they were not congruent, then I know that they're supplementary. So I'm going to write down that those angles were supplementary, which means I know that if I take one of them and the other one, so I'm going to write down the first angle, 2x plus 10, and then the second angle, 3x plus 15, I know, because these are supplementary angles, if I add them together, so I put a plus sign between them, that this entire sum is equal to 180. Now what we have is an equation that we can solve. This is different than the first equation we had, because right off the bat we knew that 180 minus 120 gave us 60. We already knew the other angle. Here, since both angles have a variable term in it, we're going to have to solve for what the variable is before we can know what either angle measure really is. So we are going to start by combining like terms. The like terms are 2x and 3x, and plus 10 is a like term with plus 15. So I'm just going to rewrite that so that my like terms are together. Of 2x plus 3x, and then plus 10 plus 15. Notice I'm also writing the sign in front of those numbers. And then I'm just going to have to drop down the 180 on the other side, because on the right side there's not any other terms. On the left side I have 2x being combined with 3x because both of those terms have x's. 2x plus 3x is 5x. Plus 10 plus 15 is positive 25, so I put a plus sign between the 5x and the 25. And then I'm just dropping down 180 because I don't have any other terms on that side. Now into the equation 5x plus 25. All of the terms that have a variable in it are already on the left, so we want to get any term that has a constant to the other side on the right, or we're going to get rid of that somehow. To get rid of plus 25, if we minus 25, we'll be left with 5x plus nothing. Since this is an equation, if I've minus 25 on the left side, we've also got to subtract 25 from the right side. This leaves us with 5x plus 0 equals 155. You don't really have to write plus 0. It doesn't change the value of anything. Now I have 5x equals 155. Just because I'm a little neurotic, I am going to rewrite that one more time. Now I've got 5 times x is 155. To undo times, we're going to divide. So I want to divide by the coefficient, which is 5. So 5 divided by 5 is 1. So I'll have 1x. 5 into 155 is going to be 31. So I know now that x is 31. That would be super sufficient and great work if I was only asked to find the value of x. But I've also been asked to find the missing angle measure of whatever angle is underlined. I gave you these directions just because that's the same directions that's on your homework. Alright, so what we know, though, is that x is 31. So I've added another thing that I know. Oops, not 31 degrees, just 31. Okay, if I'm looking to find the value of 3x plus 15, I would need to know what x is. Well, we just solved for what x is. So now I've got 3 times whatever x is plus 15. We said that x was 31, so I'll put 31 in that bubble. 3 times 31 is 93. Drop down the plus 15. 93 plus 15 is 108. So that missing angle is 108 degrees. We are going to turn this page on the back now, just because the nature of how much work I'm doing with each of these problems, I made the boxes really large, and we have a couple more examples to do on the back. By a couple, I guess I mean 4. I'm going to start out the same way by coloring in my angles using 2 different colors. So I'm going to color in the 50 with blue, and anything that is vertical with 50, or corresponding with either of those 2 pieces. So now I have all of the blue congruent angles, And then all of the other remaining obtuse angles are also congruent to each other. Okay. The two angles that they have given me information about are the 50 and the 0.5x plus 10. Now, kind of like the first example we did, sorry, before I get too far into this, 50 and 0.5x plus 10 are both blue. Since they're both the same color, then these angles are congruent. If these angles are congruent, then we already know the measure of 0.5x plus 10. Congruent means same shape and size. So I know that this size would have to also be 50 degrees. Kind of like the very first example we did, this is going to help us because you already intuitively understand that concept. So this will help us visualize and kind of make what we're about to do a little bit more tangible. So we're going to write down both angles, 0.5x plus 10, and the other angle we had was 50. We know that these are equal. Using what I know about angles, I would be able to solve that equation. This would be helpful if I was looking for the value of x. I could solve the equation and find out what x is. If I was looking for the value of the angle, obviously using the information we already had was easier. We're going to solve this equation just for some equation solving practice, and then we can talk about why we're doing this when we already know what the angle measure is. We've got 0.5x plus 10 equals 50. Our first step when we solve equations is to combine any like terms. On the left side, we've got 0.5x and 10. Those aren't like terms because the first one has a variable in it, and the second one is a constant. And then on the right side, we only have one term, so there's nothing it could even combine with. The second step is to collect variables on one side. Well, all of the variable terms, or anything with a letter in it, they already are on the left side. The next step is to collect all of our constants on the opposite side. So if all of our variables are on the left side, then we want all of our plain numbers to be on the right side. 10 is a constant, a plain number, and it's on the left side. So we want to move it to be on the right side, or get rid of it somehow. To get rid of a plus 10, we should subtract 10 from both sides, because plus 10 minus 10 is 0. So then we'll have a 0.5x plus 0. Now on the right side, 50 minus 10 is 40. I don't have to write the plus 0 because it's not going to change the value of anything. To isolate x now, I just need to get rid of its coefficient. Its coefficient is 0.5 times x. Since we're multiplying with this coefficient, to undo it, we would divide by 0.5. We do that on both sides because a number divided by itself is 1. And 1x is the same as x. 40 divided by 0.5 is 80. So I know that x is 80. Now I'm going to go back to plug in. We could plug in x for our missing angle. So we'd have half of x, or half of 80, which is 40, added to 10, 50, which gets us what we already knew to begin with. I wanted to use this example because we already can visually see that those two angles are supposed to be the same measure. This gives us a little bit of solving equation practice, because what we would do at the end, if we had two angles with variable terms, we would have to know what x is. So what we would do at the end, after we solved for x, is we'd plug the x value back in for whichever angle we were trying to solve for. Looking at the example to the right of that, I think in class I'd have you try at least one of those on your own. So go ahead and pause the video and try to do this one on your own. Hopefully you've paused the video by now. I'm going to highlight all of the congruent angles. There are only two sets of values that we're going to use here. The two angle measures that they've given us, 3x plus 15 and 150 are the same color, so I know they're congruent. I'm going to put an equal sign between them. Kind of like the first example we just did, we already know then that this angle measure is 150 degrees. If we were just trying to solve for x, or if I unfortunately had both angle measures with a variable in it, we'd have to solve for x before we could find out what either of the angle measures were. So we're going to get some practice solving for x. That way we are super helped out and understand all of the things, and we make this just a little bit harder. Add another step to being able to solve for our problem. To solve this equation, we start out by subtracting 15 from both sides. This leaves us with 3x plus 15 minus 15 is 0, so 3x plus 0. 150 minus 15 is 135. 3x plus 0, I don't have to write the plus 0 because adding 0 doesn't change the value of a number. Now we have 3x, or 3 times x equals 135. To isolate x, we're going to undo times. The opposite of times is to divide. So if I divide both sides of the equation by 3, then on the left we have 3 divided by 3 x's. 3 divided by 3 is 1, so we'll have 1x equals 135 divided by 3 is 45. Or x is 45. We can verify that that's correct by plugging in 45 for x and seeing if it equals 150. 45 is x, so 3 times 45, or 135, plus 15. 135 plus 15 is 150. This is the last two. I would encourage you to pause the video and at least try to determine if the angles given to us, 4x plus 35 and 6x minus 15 in the first example, 2x plus 15 and 3x plus 10 in the second example, pause the video and try to determine if those are going to be congruent or supplementary. So should I be putting a plus sign with an equal 180 at the end of those expressions, or should I be putting an equal sign between those two expressions? Hopefully you've paused the video by now. So I'm going to outline all of the congruent angles for both of these examples. So we can see that in the first example, 6x minus 15 and 4x plus 35 are in the same color. They're vertical, so I know that they are congruent or equal to each other. And then in the second example, again, we see that they're the same color. These are outside of the box formed by the parallel lines. On opposite sides of the transversal, these are alternate exterior angles, which we know are congruent because these two angles were vertical and they're in the same corresponding, same exact spot, so they're the same exact angle on the other parallel line. There's a whole video on that you can watch. I'm sorry, we said that they're congruent, so we would put an equal sign between them. Now in these examples, we don't have the luxury, like we did in the top two examples, of already knowing what the angle measure is. The angle measures are what the angle measure is. So we actually do, before I can solve for the underlined missing angle measure, we have to solve for what x is. So being able to set up this equation is very vital if I want to utilize this skill. To solve for x, we need to first start by combining any like terms on both sides. On the left side, I have two terms, 4x and 35. They're not like terms, I cannot combine them. One has an x and the other is just a constant. On the right side, again, I have a variable term and a constant, so I can't combine them. So that first step is already done. Now we want to collect all of our variable terms on one side of the equation. So it doesn't matter which side you try to get rid of the variables on. I usually start with the side that has a smaller number of variables. So we have 4x's on the left and 6x's on the right. I'm going to pick to move 4x's. we've got minus 4x because the opposite of a plus 4x is to minus. We're going to do that from both sides. This is useful to us because 4x minus itself is 0, and 0 plus 35 is just 35. On the right side, 6x minus 4x is 2x, and we still have a minus 15. So now we can see that this was helpful because now all of our variable terms are only on the right side. So I'm one step closer to having all of the variables by themselves and then isolating all the variables. Okay, the next thing we'll do is collect all of the constant terms on the opposite side of the equation. The variables are on the right side, so we want to get all of the constants to the left side. Okay, so we're going to start by adding 15 because the opposite of minus 15 is to plus 15. We do that on the right, we also do that on the left to keep the equation balanced. We did that because negative 15 plus 15 is 0. That's a 0 pair, and we're left with then 2x plus 0. Well, 2x plus 0 is the same as 2x. Okay. Now 35 plus 15 is 50. Now I have 2x equals 50. If we divide on both sides of the equation by 2, then we'll get 25 equals 2 divided by 2 times x is 1x, or just x. So I know in this first example we were doing on the bottom row here, that x is 25. Now that we know what x is, we can solve for the missing angle measure. Well, the missing angle measure is 6x's minus 25. So I need 6 times whatever we said x was, minus 15. Minus 15, I miswrote. That says 15. Inside of the bubble that we've written down for x, we can put a 25. Well, 6 times 25 is 150. 6 quarters is $1.50. Minus the number 15. 150 minus 15 is 135. So I know that the missing angle measure is 135 degrees. I would certainly pause the video if I were someone trying to learn this concept. That way I could practice this next one on my own and then see if I got it right. Hopefully you paused the video. To solve this equation, we'll start out by taking away 2x's from both sides, because 2x minus itself is 0, and 0 plus 15 is 15. On the right side, we have 3x minus 2x, which leaves us with 1x, or just x. We still have plus 10. Now we'll have to take 10 away from both sides. We do that because that will isolate x. It's going to isolate x because plus 10 minus 10 is a 0 pair, and x plus 0 is x. On the left side, 15 minus 10 is 5. This tells me that 5 equals x. Again, I would pause the video and see if you can use the information that 5 equals x to solve for the missing angle measure, 3x plus 10. Hopefully you paused the video and tried this on your own. The missing angle measure we want to find is 3x plus 10. I suppose since these are congruent, it wouldn't matter which one you plugged x into because they're equal to each other, they're congruent. We're just going to follow the rules here, I suppose. 3 then, 3x, or 3 with a blank spot for us to plug x in, plus 10. In the blank spot, the parentheses, I'm going to put a 5 because we said x was 5. Now 3 times 5 is 15. Drop down the plus 10. 15 plus 10 is 25. So those acute angles are all 25 degrees. And we've solved for the missing angle measure, which was our goal. If you have questions, comments, concerns about the content in this video, please don't hesitate to reach out to me via Schoology, email, any other method of contact that we have talked about extensively. in all of these videos and in class.